Our last section deals with index numbers. Index numbers are used to facilitate comparisons. And what that means is it gives us a simple way to compare measurements made at different times or in different places. You'll see what we mean by that when we start actually using them. A value at one particular time or place must be chosen as the reference. That's the value we're going to compare everything else to. Now when it comes to index numbers, the reference value has an index number of 100. And I wrote that as 100.0 because we're going to round our index numbers to tenths. Now once you have a reference value, we've got a formula to find the index numbers for all the other areas or times that we're interested in. Now, we're going to have two formulas in this section. This formula is to find an index number. This 100 on the end is actually 100.0. It is the index number for the reference. That's the reference value index number. So if I'm looking for an index number, the number on the end is the reference index number. In my formulas, whatever number is there on the end is going to be connected to the number that's in the bottom of the fraction. Now I'm only going to be dealing with two quantities, money or index numbers. If I'm looking for index numbers, my fraction is made of money. See the dollar signs? Dollar signs on top, dollar signs on the bottom. The money for the reference value goes on the bottom because it's tied to the reference value on the end. And on top, that's the money amount for the time or place in question, place we're trying to find the index number for. Here's a chart. Now, our job is to make this chart fill in that column full of index numbers. Well, to do it, this is a chart of gasoline prices, and the gasoline prices in different countries, including the United States. So we want to make a price index chart comparing all the prices around the world to one another. Well, since we're in the United States, let's just be, self-centered. And let's call the United States our reference value. What that means is the United States is going to have an index of 100.0. Now, every other country in this chart, I'm going to have to use this formula to compute the price index. So if we start at the top, if I want to find the price index for the price of gas in Hong Kong, I use my money for the fraction, the money for the place in question goes on top, the money for the reference value goes on the bottom, and then that's the index number for the reference value. On my calculator, I just do 7.12 divided by 2.12 times 100. That gives me 335.8 if I round it to the nearest tenth. Now, if I want to find the price index for Bermuda, the only thing that changes is in this formula is the top number, because for the entire chart the reference value has to stay the same. So the bottom's going to stay the same. All that's going to change is the top. So if I do this formula with 6.85 on top, that gives me 323.1 as my price index. So what I'd like you to do now is just to put this on pause and fill out the rest of your chart. Here, find the rest of your index numbers, and then restart this when you're finished. If you've completed your chart, this is what your price index column should look like. Now, just for point of fact, usually this last column is not there, but it's just sort of noteworthy. Your index number is a percentage. So what this means is if I have a price index of 335.8, if the United States is my reference value, that means the price of gas in Hong Kong is 335.8% times the price of the gas in the United States. If I come down here to Libya, price of gas in Libya is 19.8% of the price of gas in the United States. And the reference value gets an index number of 100 because the price of gas in the United States is 100% of the price of gas in the United States. Now, what do I do if I have an extra country that's not in the chart? Nothing different. If I'm looking for an index number, then my fraction is the money in the question divided by the money for the reference times 100. It just doesn't go on the chart. So I do 2.31 divided by 2.12 times 100, and that would give me a price index of it's 108.96. So if I want to round that off to tenths, the 9 has to round to 10, which makes this price index 109.0 when I round it. Now the other thing I can do is compare costs. So instead of computing index numbers, I'm going to use the index numbers I already computed to talk about money. So if I'm looking for the cost of something, in the problem, I'll be told the cost in one place, and I'm looking for the cost in the other place. Whatever the money is over here on the left, on the right, remember the right hand side is always tied to the bottom. If I'm looking for money, my fraction is going to be made from index numbers. So that's what that means. It costs $7 to fill my gas tank in the United States. So if I go to Greece with my car, how much would it cost me to fill my car up in Greece? Well, I'm going to have a fraction times my money. My money is $7. My $7 came from the United States. This 7 is tied to the bottom of the fraction. That means I go to the United States. And remember, if this is money, what goes in my fraction is price index. So when I look at the United States, I don't want the 212. I want the index number. My question is about Greece. When I go to Greece, I'm not talking about the money. I want the index number. And now I do this the same way I did the other. 289.2 divided by 100 times $7 means my $7 gas tank would take me $20.24 to fill in Greece. So this time I'm in Bermuda and it cost me $40 to fill a tank. $40 is my money, so it goes on the end. That $40 tank is in Bermuda. So I go to Bermuda, don't want that, need the price index, it goes on the bottom. Where do I want to fill it up? I want to fill it up in Libya, I need the price index for Libya. So I'm going to go 19.8 divided by 323.1 times 40 means that gas is going to cost me $2.45 in Libya. Now there's a place to carpool from. One more time if you'd like. Pause me and see if you can do this on your own. $15 goes to the right. It's $15 in Saudi Arabia. Index number for Saudi Arabia goes on the bottom because these two are linked. I want to know how much it would cost me to fill up in France, so I go to France in the chart. I want the price index for France. 262.3 divided by 44.8 times 15 tells me, France is a lot more expensive than Saudi Arabia. This is going to cost me $87.82 to fill up that gas tank. Whew. Might as well take the metro. Now the Consumer Price Index is the most famous index of all. It's used to provide an indication of inflation, which is how prices have changed with time. It's based on an average of prices in a sample of more than 60,000 goods, services, and housing costs. It's computed and reported monthly. Your tax rate is determined by the Consumer Price Index. Social Security is supposed to be adjusted to keep up with the Consumer Price Index. Such a thing like that is like when you hear about cost of living increases. The rate of inflation from one year to the next is defined as the relative change, there's that word, in the Consumer Price Index. And the government actually computes two different CPIs. The CPI-U is thought to reflect the purchasing habits of urban consumers. Urban is defined as towns with a certain minimum population. The CPI-W is the purchasing habits of wage earners, as opposed to people who are retired, people who are disabled. The people who are just out in the workforce are thought to have slightly different spending habits than those who are not. The Consumer Price Index we're going to use is the CPI-U. I have given you a copy, or you could find one online. We use the Consumer Price Index the same way we use the other index, except we'll never, ever be computing what an index number is for the Consumer Price Index, because we would have to average the cost of 60,000 different goods and services, not just, gas. So, I'm always going to use the formula that's for the money. I am going to be told money. If I have $45,000 in 1981, how much would I have had to earn in 2002 to keep my same standard of living? Well, the $45,000 is paired with 1981. What that means is I'm going to look at my Consumer Price Index and I'm going to find the CPI for 1981, and that's going to go on the bottom. The CPI for 1981 is 90.9. Now I want to know how much money I would have had to made in 2002. That's the question, so that goes on top. So I refer to my chart again, and I find 2002, and the Consumer Price Index in 2002 was 179.9. The only difference is looking up your numbers in a different chart. So if I do 179.9 divided by 90.9 times 45,000, that tells me that in 2002, I would have needed to make $89,059.41 to be equivalent to the $45,000 that I made back in 1981. Choo. What about a haircut? It's money, goes on the end. If a haircut costs $15 in the year 2000, what that tells me is the year 2000, the consumer price index for that needs to go on the bottom. Remember, this is always linked to the bottom. So the consumer price index for 2000 is 172.2. How much would it have cost back in 1980 is the question. I look in the chart. 1980, the consumer price index was 82.4. 82.4 divided by 172.2 times 15. I get $7.17. No, $7.18 if I round correctly. And last one, find the inflation rate from 1999 to 2000. Inflation is the relative change in the consumer price index. So the first thing I have to do is refer to my chart to find the consumer price index for these 2 years. 1999, the consumer price index was 166.6. In the year 2000, it was 172.2. Now, I can't find the relative change without first finding the absolute change. So the absolute change, the consumer price index from here to here went up. So I arrange my numbers so that when I subtract, I get a positive answer because it went up. And that gives me 5.6. It doesn't tell me anything because the inflation rate, I have to do the relative change. Now my relative change is 5.6 divided by the reference value. The reference is the 166.6. I can spot it because it's the one that came second in the subtraction. So I take 5.6 and divide it by 166.6, and that answer is one of the few times I want you to go to 4 decimal places. Sometimes this rate of inflation is so small that unless you go to 4 decimal places, you might not even notice it. So that means when I turn it to a percent, because a rate should be stated as a percent, I move my decimal point over 2, and this would be 3.36%.